Hi everyone, and welcome to lesson 3 of Unit 5. And for the rest of this unit, we're going to be dealing with something called transformations. And basically, it's going to be about moving graphs around on a coordinate system. And so, clearly we can draw graphs, and we've been drawing parabolas. And we've been using, we know basically if we know where the x-intercepts are, and if we knew where the vertex was, we could graph this beautiful parabola just like that. But then for the next few lessons, what we're interested in is moving this parabola around. In other words, can we shift it to the left, or can we shift it up, or can we shift it down? And so the whole idea is moving the parabola around on the coordinate graph system. So today we're going to look at, in general, translations and reflections and doing stuff with graphs, not specifically maybe about parabolas, but then in the coming lessons we're going to refocus on parabolas. And this is a really good warm-up to grade 11, because the grade 11 course deals a lot with, or starts with, moving graphs around. Okay, so this is it's a great introduction for you. All right, so we've got some definitions we're going to start with. And so a transformation is the change in the size, the location, or the orientation, of a figure. Basically, it's a change in the way it appears. Okay. A translation, so this is the general term. This is general, and now we're going to get into some subcategories. A translation is a type of transformation which slides each point of a figure the same distance and in the same direction. Okay, so just think about that. We are going to move every point. Okay, so it's the idea, let's say it was a triangle that we were moving. We are going to move every point in the same, like 3 units to the right, or 3 units up, or 3 units to the left. So that's what a translation is. It's the sliding of the figure, and we're going to slide every point the same distance and in the same direction. The resulting transformation is called an image. The resulting is called an image of the original figure. Okay. So let's look at this, and we're going to do it again. I know this unit is all about quadratics and parabolas, but for now we're going to play with some other shapes. So we're going to do some transformations with other shapes. And so it says here, triangle ABC is translated 1 unit right and 4 units up. Draw the image. Okay, so every point is going to be moved 1 unit to the right and 4 units up. So watch this. I'm going to move A. I'm going to move, and I'm going to pick a different color here. I'm going to move 1 unit to the right. There it is. I've moved A 1 unit to the right, and then I'm going 4 up. 1, 2, 3, 4. So my new A, I'm going to call it A prime, is right there. Okay, now let's move C. 1 unit to the right, and then 4 up. 1, 2, 3, 4. That's C prime. And then B, 1 unit to the right. 1, 2, 3, 4 up. That's B prime. Okay, and now I'll just draw the image. And there it is. That is the image, and that's triangle. That's triangle A prime, B prime, and C prime. It says, what are the coordinates of A prime? Well, look at this. We've moved it. We can see now that it's 2, 1. 2, comma, 1. That's the new, that's implementing the 1 unit to the right and 4 up. And interestingly, look at this. Do you agree with me that technically for the 1, we've added 1 to it? That corresponds to 1 to the right. And then -3, we've added 4 to it to get to 1. And that's the 4 up. And we're doing that for each one of these. So look at this. 3 plus 1 is 4. 0 plus 4 is 4. There, that's the new b. That's b prime. And sure enough, this last one is 5, 2. So those are the coordinates of the point. So as a general rule, this translation could be written as x plus 1, y plus 4. Every point is moved by that, by those amounts. Okay, example 2. Triangle JKL has the following coordinates. So let's draw it. Okay, so here we go. So I'm going to pick a different color. J is 0 in the x, 2. So there's J. K is 3 and then 4. So 3 in the x, 4 in the y. So there's K. And L is 5 in the x, 1 in the y. So there it is. There's L. All right, so let's draw it. I'm just going to do my best here. J, K, L. Okay. Done. And now it says draw the image of J prime, K prime, and L prime after a translation of 4 units to the left and 5 units up. Okay, so I'm going to pick a different color. So let's move J. So we'll move J 4 units to the left. 1, 2, 3, 4. And then 5 units up. 1, 2, 3, 4, 5. So there's our new J prime. Let's do K. 4 units to the left. 1, 2, 3, 4. And 5 up. 1, 2, 3, 4, 5. There's K prime and L. 1, 2, 3, 4. 1, 2, 3, 4, 5 is L prime. There we go. So basically, we've moved every point 4 units left and 5 units up. And so notice that what will the coordinates be? Well, we're going to take every x and we're going to subtract 4, and we're going to take every y and add 5. And so technically our new j should be -4, 7. Let's double check. -4 and 7. Beautiful. Okay, let's do our next one. 3 minus 4 would be -1. And 4 plus 5 is 9. Let's check it. -1, 9. Yep, that's where K is. And then 5 would be, so 5 minus 4 is 1. 1 plus 5 is 6. There it is. So the general rule for this one will be x minus 4, y plus 5. Okay, so that's the rule under which this translation occurs. Okay, let's move on to the next type of transformation. So it says here, reflection is a transformation which flips the figure over a given line or a given axis, a given line. Okay, so it's the idea of taking a shape and flipping it. So, you know, if it was a parabola like this, we're going to take that parabola and we're going to flip it. We're going to turn it upside down like that. So that's the flipping of it. Okay, the line is called the line of reflection. Okay, so in this case, the line of reflection, I'll pick a different color, the line of reflection would be right there. Okay, so that's the line of reflection. Okay, so here we go. Triangle ABC is being reflected over the x-axis. So it's basically going to be reflected over that horizontal axis, and it says draw and label the image of ABC. Okay, so essentially, every point must be an equal, if it's being reflected over the x-axis, every point must be an equal distance, from the x-axis. Okay. Well, let's do B. B's the easy one because look at this. B is on the x-axis, so is B prime. It doesn't move. If it's on the x-axis, it's got to still be 0 away. All right. Well, let's look at C. C right now is 2 digits or 2 units away. So look at this. C prime is going to have to be up here. Okay. And then A, it's 3 away, so 1, 2, 3, there's A prime. And so it's along the same vertical line, but it's the same distance away. And so here we go, we'll join those. And there it is. That is the reflection of triangle ABC, and it's triangle A prime, B prime, and C prime. Okay. I'm just going to show you here with an arrow is that we're flipping it across that line. Okay. We can use an arrow to describe this reflection. Okay. Now, what are the coordinates? Well, the coordinates of A were 1, -3. The coordinates of B were 3 and 0, and the coordinates of C were 4 and -2. I just took those off the graph. Well, what were the coordinates of the reflected point? Well, watch this, and A prime, the 1 doesn't change. It stays along the same x value, but look what happens. The y becomes +3. Look at this. For B prime, it doesn't change, and for C, the x stays the same, but the y becomes +2. So interestingly, look at this, the x values all remain the same, and the y values just became the negative, or the opposite. And so watch this. A general rule for any reflection over the x-axis is x stays the same, so the x value stays the same, but you need to multiply all the y's by -1. And really the negative, that negative there just means the opposite. It's the opposite. So just be aware that if any of those ones had been positive, they would have then become negative. Okay? Don't worry about this line. Tell me more about congruent or similar. That's okay. All right, let's try another one. All right. Triangle ABC is reflected over the y-axis. Okay, so this time we're going to be doing the reflection along this vertical line here. Okay. All right, let's do the reflection. Well, look at this. A would now move to here. I'm going to call that A prime. They're both 1 unit away from the y-axis. Let's do C. C is 1, 2, 3, 4, so I'm going to make it 1, 2, 3, 4. There's C prime. And then B is 1, 2, 3 away, so 1, 2, 3. There's B prime. Okay, so all I did was I made sure that every point was the same distance away. There's the reflection. Okay, so the original points were 1, -3, 3, and 0. and 4 and negative 2. So what do you think? What do you think the values will be? Well, in this case, the y values all stay the same. Just like in the first case, when we reflected over the x-axis, all the x values stayed the same. Well, here, all the y values stay the same, and we're going to multiply each of your x values by -1. So it becomes -1, -3, -4. And so essentially, any reflection over the y-axis is just the -x, and then the y doesn't change. Okay, so I want to get back to parabolas just for a minute, and just to basically have a glance at. So this is what we call the standard parabola here. Y is equal to x squared, or I often refer to it as the bread and butter parabola. And if we were to graph some points on this, so let's put some x values in. Let's go, let's maybe put -2 in for the x, -1, 0, 1, and 2. So those are the x values, and now let's take those x values and plug them into our equation. Y is equal to x squared to get our y values for this bread and butter one. So if I took -2 and put it into that parabola, -2 squared, well, a negative times negative is a positive, so you'd get a +4. So watch this, -2 and 4 is on that parabola. Okay, how about -1? If I put -1 in there and squared it, it would be 1. So -1 and 1 is on that parabola. 0 and 0, so there's the vertex of it. And then 1, if I put a 1 in there and squared it, it would still be 1. So 1 and 1. And then finally, if I put a 2 in there and squared it, 2 squared becomes 4. So these are the points of your bread and butter parabola right there. And so 2 and 4. Okay, so there it is. I'm going to give myself another point. 3 technically is 9, so 3 is up there, and -3 is 9 as well. So I've got to, just helps me as I draw this. So here it is. I'm going to try to freehand this. So you need to be forgiving. So I'm going up. There it is. And if I go up like that, there it is. So that's what I call my bread and butter parabola. That's y is equal to x squared. Okay, well, what if we move the parabola up by 3 units? So basically, we're going to take our points, which we know are -2, 4, -1 and 1, 0 and 0, 1 and 1, and 2 and 4. So if we're going to move it up, what are we changing? Are we changing the x's or the y's? Well, we learned earlier we changed the y's. So watch this. I'm going to do it in green here. If I move the vertex up 3, 1, 2, 3. So now my vertex is 0, 3. So look at this. My vertex is 0, 3. But really all I'm doing is I'm adding 3 to every one of my y's. So we can do this. We can go, well, it's -2, 7. It's going to be -1. The x's don't change. 4. It'll be 1, 4, 2, 7. So all we did was moved it up. Okay, so here we go. I'm just going to move the other points. So here we go. I'll now have a point there and a point there. I'll now have a point here and here. Okay, and I can't put the last one on there, but you can see what's going to happen is I've just grabbed the parabola and just pulled it up. Okay. Now, what would the equation of that parabola be? Well, what I'm going to tell you is that it's y is equal to x squared plus 3. Basically, all we're doing is adding 3 to the y values. We're going to get more into that in the coming lessons. I just wanted to show you your homework for tonight. So your homework is, here they are. You're going to be practicing some, some translations and transformations. So in question 2, they ask about, which one of them were reflections and so on. So have a look at that diagram. Number 3 gets you to practice working with parabolas. And so here, all they want you to do is substitute your -4 in for your x in each case and solve for y, or substitute in the second one, substitute 7 in and solve for y. Number 4 gets you to practice solving for zeros. So we've done that in Unit 4. So what would your zeros be here? Well, in this case, your zeros would be x equal to -5 and x equal to 3. It's whatever value of x would make that bracket 0. Okay, so that's what you're doing in that question. Question number 5, it says, well, what if you moved at this point, if you moved it 2 units left and 5 units up? So think to yourself, well, here 2 units left means it would be x minus 2, and 5 units up would be y plus 5. So just that's getting you to practice that. Here they're asking you to describe the transformations of those triangles. And then here they're getting you to practice with some quadratics, axis of symmetry, vertex, just to review those things with you. And then these last few are just, again, working with some quadratics. Okay, so the answers are on the last page. Give those ones a shot and let me know if you have any questions. Take care, you guys.